Okay, this is going to be a lesson on dimensional analysis, and that is a word that freaks out chemistry students. It is two four-syllable words put back to back. I mean, people just freak when they see dimensional analysis. What it really is it's just a way for us to change the units on a number without changing what the value of the number is. It's a way of converting from one unit into another unit. And there are, we're going to basically do is multiply fractions together. Fraction times a fraction times a fraction times a fraction. And there's two real important things that you want to keep in mind when we're doing dimensional analysis, and you can check each problem this way. If these two things are true, chances are your answer is probably right. If every fraction is equal to unity, which is kind of like equaling 1 in a real weird way. We'll talk about that in just a second. And if all of the unwanted units cancel out, that means that you are well on your way to the correct answer. One of the best things about dimensional analysis is that the answers kind of like work themselves out. The units guide you, and if you both of these things check out, you almost have to be right. Okay. So what does this idea unity mean? Well, if everything, every fraction that we have equals unity, it's kind of like equaling 1, and that means that when we take a number and multiply it by 1, we aren't changing it. So what we're doing is we're taking and multiplying by 1, multiplying by 1, multiplying by 1. So we're not changing the value of the number. We're only changing what its units are. But unity doesn't actually equal 1. I mean, you can look here at this and say, Mr. P, that 100 divided by 1 meter does not equal 1. And you would be right. It does not equal 1. It equals, it's 100. But the idea of 100 centimeters and the idea 1 meter are the same idea. So in a real like philosophical, theoretical kind of abstract sense, this fraction equals 1 because we have an idea divided by the same idea. And so it's kind of like being 1. And when you have a fraction that is equal to unity, you can flip it, and even if you flip it, make it reciprocal, it's still going to equal unity. It's kind of like equaling 1. And we use these fractions stacked next to each other in order to make a conversion. Let's start off with a really easy one. It's important that you learn this process. Now this calculation, convert 54 centimeters into meters, that's not a hard calculation at all. In fact, I hope that most of you have got the answer in your head just looking at this thing. But I'm going to use some simple calculations to teach you to do this process, which is more important than the result of the calculation. Okay? So what we'll start off with is we'll start off by taking 54 centimeters, which is the number that we wish to convert. And like I said, we want to make everything a fraction when we do dimensional analysis. So the way we make 54 centimeters into a fraction is we put it over the top of the number 1, which makes that a fraction. And then what we want to do is we want to multiply this by a fraction. And we want to do it in such a way that the units are going to cancel out and that we are going to come closer to being in meters. Now, I happen to know, and hopefully you do too, what the direct conversion is between centimeters and meters. So we can do this calculation in one step. In just one fraction, we're going to figure this out. And what I want to do is I want to cancel unwanted units. So I want to put centimeters in the bottom here. And that way I know that the units will cancel out. The centimeters in the numerator here will cancel the centimeters in the denominator there. And then I'm going to put meters on top because I know a conversion from centimeters to meters. Okay. Now carefully, you want to make sure that you put in these numbers. I'm going to put 100 centimeters is 1 meter. If you aren't careful, if you get in a rush about this, it's very easy to write down this instead. And I've done that before myself, and if you check this, this fraction right here does not equal unity. The idea on the top and on the bottom, 100 meters and 1 centimeter, are two very different things. Up here, we look at this one, 1 meter and 100 centimeters is the same idea both above and below. This fraction equals unity, so it checks out and we can go. But we're actually already at the answer. We wanted to have our units in meters, and here they are. So what we do is we take the numerator, 54, times the numerator, 1 meter, and we have 54 meters is the result of that multiplication. 1 times 100 is 100, and our answer ends up being 0.54 meters. Again, this is a very easy calculation, but we're just trying to show you how to do this kind of calculation using a simple start. If we go on to another one that maybe is also simple, but maybe one that you don't do in your head quite as easily, we could talk about seconds and minutes. convert 10 seconds into minutes. Take 10 seconds. In fact, let's make it 10 point seconds. If we make it 10 point seconds, that gives us 2 sig figs, and our answers are probably going to be a lot better because of that. So 10 seconds. And what we're going to do is I'm going to do it in a slightly different format this time. I'm going to draw one bar to separate the numerators and the denominators, and I'm going to use vertical lines to separate the fractions. This is called the picket fence method. And it's the same thing. If you like the other way, do it that way. If you like the picket fence, do it this way. We're going to make this a fraction by putting it over 1. So 10 point seconds, 10 with 2 sig figs, seconds. And we want to go into minutes. So we want to put seconds on the bottom here. And if we know a direct conversion into minutes, which I think we all do, we can put minutes on the top. And the reason we put seconds on the bottom is because we do not wish to have an answer in seconds, so we want to cancel that out. So if I put seconds on the bottom and minutes on the top, my next step is to fill this in with numbers that will give me a fraction equal to unity. So the conversion between seconds and minutes is that there's 60 seconds in 1 minute. And now if I finish, my answer is going to be in minutes. So what I do here is I multiply the numerator times the numerator and the denominator times the denominator and get what my thing is going to be here. So I have 10 point times 1 minute gives me 10 points, so that's 2 sig figs, 10 minutes, divided by 1 times 60 seconds gives me 60 seconds, or actually just 60, the seconds have been canceled, and that is equal to 0.17. So with 2 sig figs here, this conversion, this is something worth stopping to talk about. This conversion is considered perfect, so both of these numbers have got an infinite number of significant figures because the very idea of 60 seconds in a minute is perfect. However, this 10 seconds here, we put the decimal point in there to show that this is a measured quantity, and that's got 2 sig figs because the decimal point there, bigger than 1 with a decimal point, they're all sig figs, so 1 and 0 are both significant there. So because there's 2 sig figs in that, I should have 2 sig figs in my answer. 0.17 minutes is my answer for this calculation. All right. Let's do one that's maybe 2 steps, a little more complicated. Convert 1 pound into grams. We're going from the standard English system into the metric or scientific system. And there's no cute way to do this. If you know the conversion straight from pounds to grams, that's one thing, but I'm going to make you do 2 steps here. So let's start off, let's make this 1.0 pounds for sig fig's sake. 1.0 pounds, and we're going to make that into grams. So let's put that over 1 to make it a fraction. And what we are going to do now is we want to think about what can I do with pounds to get it closer to grams. I don't know any conversion straight from pounds to grams, but the information up here gives me a conversion between ounces and grams. And I do know that 1 pound is 16 ounces. And so what I've done here is I've set this up so my pounds cancel my pounds. And I check this fraction here, and that is equal to unity. 16 ounces and 1 pound is the same idea. So I'm ready to go. I can continue on. I've multiplied that first fraction by a fraction equal to unity, and now I'm in ounces. If I were to stop right now, my answer would be in ounces, but they asked me to give them the answer in grams. So I'm going to carry on, and I'm going to use this conversion from up here and bring it down and say that 1 ounce is equal to 28.4 grams. What I've done is I've canceled my ounces, and now I'm into grams. And when I calculate this guy out, I have 1 times 16 times 28.4 grams, and I get 454.4-ish grams over 1 times 1 times 1 gives me over 1. So my answer to this calculation is 454.4 grams. Now, I should be able to round that with the correct significant figures. 1.0 pounds was a measured quantity, and it has 2 sig figs. 16 pounds and 1 ounce is a perfect idea. That is a perfect conversion, and therefore both of those numbers contain infinite significant figures. And 1 ounce is 28.4 grams. That is a conversion between metric and standard and is not perfect, and so I'm going to use a perfect ounce. 1 perfect ounce, there's 28.4, so I'll stick with that 28.4 and say that there's 3 sig figs. We could go to 28.4 something, something, something and get more. We've chosen to stop at 3, so because I've got 2 in this number, and it's all multiplication and division in this problem, that means I need to round this answer to 2 sig figs. So the closest number I can get to 454.4 with 2 sig figs would be 450 grams. Let's do one last one together here. Convert 5 kilometers into miles. Take a second, pause the video if you want, and shoot this conversion from kilometers into miles. Starting off with 5 kilometers, let's make it again let's make it 5.00 kilometers. We'll make it a good race here, so it'll make it well measured. In a good 5K, they go to great lengths to measure the length of the race to say that it is exactly 5 kilometers. 5.00 measured down to the hundredth of a kilometer there. That's easy enough to do. We want to convert that into miles. So we'll do picket fence style again for this one. Whichever one is more comfortable for you is fine. We'll make that a 1 to make 5 kilometers into a fraction. And now I'm going to make sure I put kilometers on the bottom, and I want to convert into something that's going to get me closer to miles on the top. Looking up here, I don't have any straight conversions from kilometers to anything useful, but I do know that from my metric prefixes that 1 kilometer is 1,000 meters. And so I've put the kilometers such that they cancel each other out, and now I'm into meters. And once I'm in meters, I can use these conversions up on top here. It says that to me here that 1 meter, and I can go into feet, and the relationship is 1 meter is 3.28 feet. That's equal to unity because the idea above and below is the same. So this fraction is equal to unity. This fraction is equal to unity. We're in feet now. If I were to stop right now, my answer would be in feet. How many feet long is a 5 kilometer race? But we don't want it in feet. We want it in miles, and so I have to go from feet into miles. I'm going to cancel my feet out, and I'll have my answer in miles. It turns out, as you can see above, is 5,280 feet in 1 mile. And as I calculate this out, I take the numerator times the numerator times the numerator times the numerator, and then divide that by the denominator times the denominator times that, blah, 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 blah. And we end up with 3.12 miles for our answer. And this answer has got 3 significant figures, and that's good because, well, this conversion is perfect. This particular conversion is from meters to feet, so that's got 3 sig figs. This conversion is perfect, and this was measured out here, so that's got 3 sig figs. So my answer should have 3 sig figs. That's what we find down here, so 5 kilometers is 3.12 miles.